This is the Calculus Pre-Lecture Series. I'm Brandon Ashley, and this video is on polar coordinates. So if I asked you to describe this point in space, you might throw a coordinate axis on there and say something like, well, the x-coordinate is 3 and the y-coordinate is 2. So you can write this point as the ordered pair xy equals 3, 2. And if you did that, you would have written the point in terms of its Cartesian, or its xy coordinates. And these are perfectly fine coordinates to use, but it turns out that there are other ways to describe a point in space, and one way is using polar coordinates. So polar coordinates don't rely on the x and y axes. Instead, they rely on circles centered at the origin. And so if I drew a circle which goes to this point and the circle is centered at the origin, then the circle is going to have the radius r, which goes out to that point. And I need to specify where on the circle the point is, so I need to come up with some angle from the x-axis, which tells me where on the circle I am. And so in polar coordinates, instead of using x's and y's, we instead use r's and thetas, where r is the radius of the circle centered at the origin, and theta is the angle from the positive x-axis. So for any point out in space, we can always specify it in terms of its Cartesian coordinates, or we can specify it in terms of its polar coordinates. And it's always good to be able to go back and forth from one to the other. So if I was given something in polar coordinates, I want to know how can I go back to Cartesian coordinates, the xy coordinates. And one way to do this is to make a right triangle by dropping a vertical line to the x-axis. And if I have this right triangle, then the adjacent side here is just going to be the x-coordinate, and the opposite side is going to be the y-coordinate. And we can start specifying parts of this triangle using trig. So we can say cosine of theta is going to be equal to the adjacent side over the hypotenuse, or just x over r, and sine of theta is going to be the opposite side of the triangle over the hypotenuse, or y over r. And if I want to get out the x and y coordinates, all I have to do is solve for x and y, which gives x equals r times cosine theta, and y is equal to r times sine of theta. So if I'm given the point in terms of its polar coordinates, r and theta, all I have to do is plug them into this formula, and I get the Cartesian coordinates, x and y. So let's see an example of this. Given the point 2, pi over 3 in polar coordinates, we want to plot the point and then find its Cartesian coordinates. So if we have the point 2, pi over 3, that tells us that the radius r is going to be 2, and the angle theta is going to be pi over 3. So just like when we plot in Cartesian coordinates, we're going to plot, but this time we're in polar, so we're looking at radii and angles. So I'm on the r equals 2 radius, which means I'm somewhere over here on the r equals 2 radius, and I need to go up to theta equals pi over 3, which ends up being this tick mark here is pi over 3. So I move up to pi over 3, and that would be my point in polar coordinates. And we also want to find the Cartesian coordinates, and we do this using our formula. So we know that x is going to be equal to r times cosine theta. And if we plug in those values for r and theta, we get 2 times cosine of pi over 3, which you can calculate is just going to give us 1. And we do the same for y. We get r times sine of theta, which is going to be 2 times sine of pi over 3, which again you can calculate is just going to give the square root of 3. So the Cartesian coordinate is xy equals 1 square root of 3. And we can check that on our graph. If we look here at 1, that's about where our dot was. It's exactly where the dot should be. And square root of 3 is a little less than 2. And if we look here, we're a little less than 2. So we can also talk about equations in polar coordinates. And if we wanted to graph the polar equation r equals 2, we would set up a table. So we'd have theta values and r values. And when theta equals 0, we'd have r equals 2. So we could plot that. Theta 0, r equals 2. When theta equals pi over 4, r is going to be 2. And r is 2 everywhere, so it would stay that way. So if we look here, for all values of theta, I get 2. And so I just trace out this circle, and it's a circle of radius 2. Circle of radius 2, centered at the origin.